welcome to Podcast.Init, the podcast about Python and the people who make it great. I would like to thank everyone who supports us on Patreon. Your contributions help to make the show sustainable. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at www.podcastinit.com/Linode and get a $20 credit to try out their fast and reliable Linux virtual servers for running your next app. Do you need to learn more about how to scale your apps or learn new techniques for building them? Pluralsight has the training and mentoring you need to level up your skills. Go to www.podcastinit.com/pluralsight to start your free trial today. You can visit the site to subscribe to the show, sign up for the newsletter, read the show notes, get in touch, and support the show. To help other people find the show, please leave a review on iTunes or Google Play Music, tell your friends and coworkers, and share it on social media. If you work with data for your job or want to learn more about how open source is powering the latest innovations in data science, then make your way to the Open Data Science Conference, happening in London in October and San Francisco in November. Follow the links in the show notes to register. Your host as usual is Tobias Macey, and today I'm interviewing Scott Moser about Cloud-Init, a set of Python scripts and utilities to make your cloud images be all they can be. So Scott, could you please introduce yourself?
Hello, this is Scott Moser. I am a Ubuntu core dev and employed by Canonical, and I am the primary maintainer of Cloud-Init. Been working on that for, I think, probably going on 7 years at this point.
And were you around when the project got started, or did you get involved after it was already in motion?
I started very close to the beginning. At that point, it was called EC2Init, and it did probably about 1% of what it does now, and it was very young in its life cycle. It was originally started by someone named Soren Hansen, who has gone on to other things since then.
And do you remember how you first got introduced to Python?
So I first got introduced to Python largely just as a language that I saw code being written in, and I had to work with. I worked at IBM in the Linux Technology Center, and so a lot of my job was touching a wide variety of different softwares that make up a Linux distribution or contribute to different things. And so inevitably you come across Python. And so that's where I got an introduction. I'd say that Cloud-Init is probably my first large introduction to Python, and I think that probably shows in some of the older bits of code that are there. Over time, I think I've improved a little bit, and hopefully the code is better written now than it was, and improving always. So.
And you mentioned that the initial incarnation of the project was as EC2Init, so I'm wondering if you can just briefly describe what the Cloud-Init project is and some of the history of how the project got started, and also the reason for Python being the language for implementing it.
The initial beginning would have just come from the time when Canonical was putting images of Ubuntu on Amazon, and so inside those images, you needed to do a couple things, the simplest of which was just consume user data that can be supplied to a instance at launch time and react to that. The first thing that was there basically grabbed the user data, and if it started with a shebang, it would execute it. So that went a long way. And then EC2Init came as a Python implementation of what was there, but was EC2 specific. And then so at some point during the lifespan of the project, we added support for OpenStack and different clouds, and at which point we decided to take the EC2 portion out of it and make it more generic. Yeah, so as far as the language and why Python was chosen, I think that it definitely at that point in time, it would have been like 2009 or 2010, a lot of Ubuntu development was being done in Python, and still is the case. You know, it's definitely a very strong language choice due to its presence on just about any Linux, and just the ease of use and ease of development that comes with Python.
And so the user data input was already present on EC2, and Cloud-Init, at that point EC2Init was used as a way of consuming that. So before the EC2Init project, do you know what the sort of use case for that user data input was for other distributions on the EC2 platform?
That's a good question. So honestly, the first images, to my knowledge, that were put up in any sort of public manner were done by a contractor for Canonical, and he used, I believe that Eric Hammond came up with the idea of just executing the user data if it started with a shebang, and I think that was a wonderful idea, and magically increased the functionality of a stock image to do automation on it. Now, what other things we're doing with user data at that time, I'm not real sure. I think, Amazon designed it as just I believe it's limited to 16K binary blob. And it was just kind of a way for you to feed data to the instance, and then the instance would decide what to do with it. To my knowledge, though, the first user of that was Ubuntu's images to at least use it as consumed shebang.
And so since the time that Cloud-Init was introduced, it has grown to become the de facto utility for managing cloud instances across vendors and distributions as far as being able to consume that user input at boot time. So I'm wondering if you can share a bit about how that journey has progressed and how you think Cloud-Init has come to become that de facto standard.
So Cloud-Init, initially the shebang, just executing user data that started with shebang, got you so much for so little effort, and it was really just a fabulous idea. But then, as over time, we wanted to be able to do some more things, and wanted people to be able to declare things in a more declarative language, to configure Ubuntu or another operating system in a more declarative manner. So the first thing I think maybe that was added would be just the ability to say these packages should be installed and give a list of packages. And then Cloud-Init got some function to be able to write files that you could add you could declare some files, their path, their permissions, and their executable mode, and then Cloud-Init would write those down. So over time it just kind of grew in function and hopefully also usability. Now, I think as far as to how it became the de facto standard, I think the largest contributor to that was Cloud-Init's presence in Ubuntu and Ubuntu's success from a Web 2.0 operating system perspective. Basically, it being so popular to use on Amazon initially, and then onto other clouds. So, people chose to pick Ubuntu, and then by that nature, then they were able to use Cloud-Init. That has also then helped, that it helped Cloud-Init get into other operating systems, your CentOS or RHEL, and because people were familiar with it on Ubuntu.
As far as you're aware, are there any other viable competitors to Cloud-Init that other distributions are making use of?
CoreOS, when came out maybe 3 or 4 years ago at this point, and they looked at using Cloud-Init, but were unhappy with some facets of it, and so they chose to implement one of their own, and they chose to do so in Go. So there is a CoreOS Cloud-Init which consumes a portion of the cloud config that Cloud-Init does. And then there's another similar project that works on OpenStack. It has a smaller footprint than Cloud-Init does and smaller functionality, but kind of basically just enables the OpenStack data source for users to interact with that. That name is eluding me at the moment, is why.
Well, if you come across it, we can add it into the show notes afterwards. So a lot of the use case for Cloud-Init is to be able to bring your cloud instances to a particular known state during boot time, which is also a large portion of what configuration management tools such as SaltStack, Ansible, Chef, Puppet, etc. are used for. So I'm wondering how much overlap you've seen between those two sort of bits of tooling and how much of a crossover there is as far as people using Cloud-Init to bootstrap their configuration management or vice versa.
Yeah, so my feeling, the initial intent for Cloud-Init was that it was in fact init, that it would be a way to initialize your instances and kind of get them to the next thing. So I think one of the early contributions from someone other than myself to Cloud-Init was to enable you to declare Puppet configuration, and then Cloud-Init would install the Puppet package, lay down the Puppet configuration, and then join in with your Puppet system to let it take over. And that's kind of still, I think, the primary use case, and I really think it's valid, is that you already have some management system already present, and you kind of want to make use of that. Cloud-Init, also another user of Cloud-Init, which is similar, is Canonical's Juju. When it launches instances, it declares some things to Cloud-Init, which then help it to integrate with its daemon and go from there. We do have support for Salt and Ansible and Chef all similarly in Cloud-Init, to where you can basically bootstrap and get to those as a management infrastructure. So as far as going past that, I think Cloud-Init we've had requests for Cloud-Init to do things post-boot or to do more life cycle management, and I think that those sorts of things will come over time. I still definitely want to, at all points, I think that there will exist other instance management solutions, and so Cloud-Init should integrate with those and basically allow you to get to those, and then not preclude you from using them.
And given that Cloud-Init needs to be able to run across multiple different distributions and cloud environments, how have you architected the project in order to be able to minimize the amount of sort of rework and ongoing maintenance that's required to be able to maintain that compatibility?
So I think there's probably two axes of variation in Cloud-Init. You've got a data source, which is in Cloud-Init lingo, which retrieves information from a cloud platform. So that would be Amazon or Azure or DigitalOcean or IBM SoftLayer, and then you've got the distribution, which is the other path. And so the data sources are fairly well separated out. They're not as well architected as I'd like, and we're doing some work to kind of improve how they're used, how generic they are. So we'll have more consistent use of them at some point in the near future. And then the distribution also, when at runtime, code that is distribution specific runs through a distro object, and then the distro object can handle doing some of the interaction with the operating system, such as installing packages or configuring locale or setting up NTP or TimeSyncD. That sort of stuff goes through the distro.
And what are some of the most difficult or complex aspects of building and maintaining the project?
So I'd say by far the most difficult thing has been the initial goal that I set out with, which was when you launch an instance, you should be able to take a generic instance and turn it into one just like you would have customized yourself without doing a reboot and without having to restart services. So the goal there was that Canonical was making images and publishing them to different clouds, and we wanted people to be able to use those without having to figure out how to build their own images and publish their own images and deal with all the heartache that is involved there. We wanted to be able to publish something that would be usable immediately to anybody. So what that meant was that Cloud-Init needed to run very early in the operating system in initialization so that it could affect later parts of boot. And so that tie-in with the operating system, it has been complex, especially across the different Linux distributions and different init systems that you have. Still Cloud-Init supports System 5 init, Upstart, and Systemd at this point, and then also runs on FreeBSD, which is more of a sysv init. But integrating with the operating system has been the difficult thing, and guaranteeing the points in boot that I'm interested in allowing people to interact with. The second thing that's been of real interest is lately we've had a focus on getting networking support into Cloud-Init, and by that it means being able to read the information that is available on the cloud platform and apply it to the operating system. So on Amazon, there's not really a lot of network configuration you can do. You can get additional IP addresses or additional NICs, and at this point, Cloud-Init doesn't do a good job of taking advantage of them there. But on other operating systems or other cloud platforms like Joyent's SmartOS or OpenStack, we get a fairly rich declaration of networking. That may include IPv4 and IPv6 or multiple IPv4 addresses or IPv6 addresses across multiple NICs with different routes. And so Cloud-Init is being changed to be able to read that information and apply it to the operating system so that the operating system comes up as if it were initially configured in the image. That's been somewhat difficult in that it really stresses the tie-in with the operating system. And honestly, the networking solutions, I've been very surprised at the networking solutions on both Ubuntu and on CentOS, or on RHEL, where we've done this most thoroughly. It's really quite surprising how hard it is to declare networking in a way that is that will reliably come up. Some issues we've had have been with static routes being declared and when to raise them, and just different interaction with networking that we've come across when we've really pushed automation of it, that has really fallen out. I think that we're taking care of a lot of that stuff, and at this point you can fairly well declare networking to Cloud-Init and have it come up, but it wasn't easy getting there.
Yeah, networking is always sort of the bugaboo of anybody having to deal with systems, because while there are a lot of really robust standards that are in place, the actual implementation and interaction of all the different layers of those standards can become quite difficult to be able to understand and reason about. And particularly the implementation of some of the finer points across distributions and across network environments in general is highly sort of unique between different environments and different use cases. So
right, yeah, that's exactly it. And so for example, in Canonical's MAS, Metal as a Service, they can declare to the installer, which then at this point is passing that through to Cloud-Init, that they'd like that there exist these 3 NICs. They'd like 2 of them bonded together and a multiple IPv4s or IPv6s on them, and what's it called? What's the networking that sits on? Man, I can't think of this.
Oh, the VLAN.
VLANs, yeah, right. Gosh. So essentially you can put a VLAN on top of a bridge, on a VLAN on top of a bond, or on a bridge, and all of that stuff. Basically anything that you could have modeled, now you can declare in a language to Cloud-Init, and it can render it into being on Ubuntu and as much as possible on RHEL or other operating systems. And it's just amazing at how finicky a lot of those networking systems are, especially given that the dominant network operating system in the world is Linux. And these 2 platforms that I'm trying to interact with, and it's amazing at how many edge cases we've hit.
And your point too about being able to pass that information along to the different layers, it brings up one of the issues that I've seen a few times working both with Cloud-Init and other systems, particularly where you have a declarative language that you're then trying to interpret into commands to multiple different tools, is being able to propagate that information appropriately and mutate the data structures as needed, so that it's easy for an operator to be able to input the information, but then it also gets put into a usable form for the end tool, which may need it in a completely different format. So maybe you're writing it in YAML, but you need to render it in XML or something like that. So What are some of the ways that you've tried to mitigate some of the pain of translation, both from the user perspective and then also within the system?
In the state right now where we are, we're lucky and we're trying where it's fully declarative, and right now we don't really support kind of user interaction after the fact. And so as long as you can get it right on the first boot, you're okay. I realize that's not a tenable position going forward. We're going to have to allow for users to, to append or improve their, make changes to their networking and Cloud-Init be able to handle that well. But yeah, it's been interesting. I'd say that the biggest piece of sanity that we've gotten out of this is another project I work on is called Curtain. It's the Curt installer, and so it's a basically fast path installer for Ubuntu. But in doing its test cases, we have it's called VM test, and actually we do an installation to a system where we can declare whatever networking we want across. We can attach multiple NICs and declare the networking, and then we do the installation, we boot the system up, and then we verify that the networking is set up as we expected. Now, we don't actually test network traffic at this point, but we are checking that the devices get created, the devices are stacked correctly, that basically the system appears to be completely functional, but we don't actually have a VLAN set up that we would do VLAN traffic on to verify it. But it's completely all done in an automated fashion, so it's really nice.
And one of the complexities that I've seen while working with Cloud-Init is the ability to verify your configuration, and generally that manifests as just put in the Cloud-Init information, launch the instance, and cross your fingers and hope for the best, and then try to debug any issues that come up. So you end up running through some fairly long cycles of write your config, boot, wait for everything to apply, and then retry if you get it wrong. So are there any ways to short circuit that cycle where you can actually verify things locally before you have to push it to the cloud?
Yeah, so that's a real pain, isn't it? And that is one of the largest bits of feedback we've gotten. And it was one of the reasons one of the things that CoreOS and their Cloud-Init implementation really tried to address. There's a couple things that can help in that scenario. We're doing development right now on using Python JSON schema or JSON schema to declare what each of those config snippets can look like. And one of my coworkers, Chad Smith, has just been working on adding JSON schema and validation to some of the modules. So over time, we'll add JSON schema validation to different modules, and with an end goal of being able to have a web page or a command in Cloud-Init that you can say, hey, validate this as correct input, and get well annotated. He's done a really good job of annotating on line numbers and everything, the output of where you have an error. So that'll really go a good long way to helping with that. The second thing is for declaring if the input is in the right format. Unfortunately, there's more inputs than just a cloud config, right? The data source, or on a given cloud, you may have multiple disks attached, or you got multiple NICs attached, or there are more variables than just what is there. And then also if you're providing something like packages to install or commands to run, or there's kind of a lot of extra inputs and a lot of extra potential for error. And so the thing that I've done that is most useful to quickly iterate on those things and kind of shake out issues early. The thing that's been most useful has been LexD. And not to just tout a canonical product because it's a canonical product, but LexD, previously known as LXC, is an amazing piece of technology that you can launch start a container. It's a full system boot of a container. So just about anything you can do with Cloud-Init on a public cloud, you can do with it inside of a container. But the startup time is, measured in less than 10 seconds, and the teardown time and the cost is about zero. You can launch an instance on DigitalOcean and be paying $10 a month and have that as your development, as a system where you launch dozens of containers inside of it, interact with them, verify them, and then tear them down. So it's a real boon to quick development iteration.
And given that Cloud-Init has become such a critical component of so many people's production deployments and the mechanics necessary to ensure that they have their system in a known good state, what are some of the approaches and tooling that you've put in place to ensure that there's an appropriate level of stability and security while you're developing Cloud-Init and trying to maintain a forward progress on the feature set, but also preventing any regressions or backwards incompatibility?
The biggest thing we have right now is work on the integration test suite. So we've got contributed by another person, Wesley, who was one of our interns, fabulously capable college student. He contributed a integration test suite that launches instances right now on LXD. And so we can get a whole lot of validation of cloud config and other interaction with Cloud-Init that way by just launching an instance and then inside of it verifying that things look like they do. And so we can get a whole lot of coverage of the path for Cloud-Init via that. Now, our next steps in development are to extend that to running on different platforms also. So in addition to being able to launch an instance on LXD, to be able to launch one on Amazon or Azure or Rackspace or IBM SoftLayer or any of the other clouds, and then with that integration test suite in place, basically being able to take trunk, pull an image, shove the new Cloud-Init into that image, publish it to the cloud, and run through a battery of tests on it. So that's the best path we have to sanity there. And there are a lot of variables there. The operating system is moving underneath you, and they have a lot of different platforms. So to be perfectly honest, at this point and over the past, it's been hard to maintain stability, and due to the complexity of kind of what's going on there. So, but that's a primary thing we're targeting at improving. Now, for security, Cloud-Init kind of sits in a place where security is not so important. I don't ever want to imply that security is not important, but Cloud-Init runs as root and consumes data from the metadata service on the cloud provider. If that happens over a network, then if that network is compromised at a point early in boot, you're kind of open to a lot of attack anyway, and there's not a whole lot you could do about it. Obviously, there are things that we could come up with to improve it, but it kind of sits at the point where if your system is vulnerable to attack that early in an instance lifetime, that there's likely to be trouble. Again, I don't want to discount security as an important thing by any means, and as we go forward, kind of extending to post-boot action, it will be more and more important.
Yeah, I definitely agree that given the fact that it is running as root and at the very beginning of the instance lifecycle, there's only so much responsibility that you can really take on, and it's important to define the limits of what your sort of commitments are in terms of ensuring any measure of security. So given the nature of the project, it's definitely largely placed upon the user to ensure that the inputs that they're providing and the way in which they're providing that input is done in a manner that's going to prevent any sort of exploits, and the tool is basically just consuming whatever it's given, and you can't really be expected to prevent users from doing foolish things.
Right. So Cloud-Init is in some way is a arbitrary command execution platform, right? by one of its design points. So if you give it arbitrary code to execute, it will happily execute it. Now, it is upon Cloud-Init in many cases to make sure that code that is coming from a source that you intended, and not to mess up and pull it from somewhere else. But that's kind of the limits of it right now.
And how do you think that the status of Cloud-Init as a canonical project and the fact that the development happens on Launchpad as opposed to the ever ubiquitous GitHub, how do you think that that has affected the level of contributions and the type of input that you've received as the project has progressed along its lifetime?
So let's see. So a couple questions there. So as a canonical project, I think, there, for whatever reason, there definitely is a set of people who are not interested in contributing to a canonical backed project, or may at least initially balk at the opportunity to do so. That said, Cloud-Init has been successful as a upstream project that has been, accepted into distros and is a proper part of many distributions. So we've kind of overcome that. I won't pretend that there weren't some hardships as a result, but I think that largely that's accepted now as just something that is, and we act as a reasonable upstream, and so the track record of doing so helps people to realize that they shouldn't worry too much about that. But that said, we have during one point in the lifetime of Cloud-Init, we've moved as a result of user input from being a GPL2 license to what is now dual licensed as Apache 2 or GPLv2. I say that, but I want to make sure that I'm sorry, GPLv3. So it's now dual license under Apache 2 or GPLv3. And actually, I think the license change there made people really squash some concerns that people had and, felt more compelled to contribute. The second part of your question was with regard to Launchpad. I'll expand on that. Initially Cloud-Init was in BZR on Launchpad, and I want to say that if you're a developer of a piece of, if you're a software engineer and you've got a problem with a piece of software, or you want to improve a piece of software, and you come across the fact that it's in a revision control system that you're not familiar with, the reality of that stopping your contribution, I think, is small if in fact you were really interested, right? If you want to accomplish if you need to accomplish something at work, and and all sorts of times we come across a new piece of software that we have to interact with, that we have to learn as a result. It's not really something a justifiable complaint in my brain, but however, it I think it's used more often as an excuse. However, as we moved from BZR after BZR was kind of marked as end of life, we moved off of BZR and over to over to Git. I think that change did help, and I mean, it definitely removed a variable of restraint from people. So we have gotten some more contributions there, I think, as a result of being on Git. And actually, definitely, I have enjoyed being on Git, and the freedom and the ability to do some things that were difficult in BZR. I really enjoyed that. Now, lastly, the Launchpad versus GitHub argument or question, I think, really similar to, if you're not willing to learn a new piece of software to contribute to a project, then probably weren't really that interested. I think the same is true for Launchpad versus GitHub. There is the one initial pain point is that you have to go and set up a Launchpad account, right? And maybe you didn't have one before and you already did have a GitHub. So, there is that burden to entry. I don't think that in itself has cost us much. I think more so the barrier to entry that has cost us was BZR, even though I argued that it shouldn't have.
And how much of the overall contributions that you do receive are from some of the other corporate users of Cloud-Init, such as the cloud providers like AWS, Azure, etc., versus individual contributors who are trying to fix a particular use case that they're having trouble with?
I'd say the breadth of contributions probably spans people that are looking to fix something or come across one problem and want to fix it. So the majority of let's see, the number of users, if you went by that, the majority of the people who contribute are probably looking to fix one thing or just contribute a small thing. But the majority of the work, and at this point still the vast majority of the work has been paid for by Canonical, but there are substantial contributions from both from operating system providers like SUSE or Red Hat or FreeBSD and also by cloud providers such as Azure has got contributions in and Amazon has got contributions in. So I think the most active contributor at this point outside of Canonical, I think has to be actually Red Hat. The guys who are maintaining Cloud-Init on RHEL have been active in participating and have been just really done a good job of contributing in a way that's been good for the overall project rather than just good for Red Hat. They've done a good job of adding unit tests where they need them or where they add code, and not just looking to drop a fix for exactly their issue and then run away. So I really applaud their work there. They've done good.
And what are some of the most unexpected or creative uses of the Cloud-Init system that you're aware of?
So yeah, there's a couple I think I've been real happy with. The first was that Canonical made these Ubuntu images, and now other operating systems make these images. I know Debian does, and you can download a cloud image for CentOS or download one for SUSE or build your own for SUSE. The biggest boon I got was when I added the no cloud platform or data source to where you can launch an instance, or you can download this image and add a second disk when you launch it that has some user data, metadata, and then just launch that locally in KVM, in your KVM, and interact with it. I think that's really useful for people to if you just want to see Ubuntu server in Artful and see how it is right now. Honestly, the easiest way for you to do that and cheapest might be to take that path, to launch an instance, to give it some user data that says set the password to password and boot it up and log in. And so that's been a big help, and I think helped Ubuntu in general and also Cloud-Init. The one that surprised me really was Open Compute has this idea of a disposable use OS, and this isn't something I'm terribly familiar with, but one of my coworkers was involved in Open Compute and was kind of pushing this as, well, this should be Cloud-Init. And so I believe that on any Open Compute platform, you can kind of boot into something that can be driven through Cloud-Init, and then on just through its kind of BIOS or its attached disks, it will go into that right away, and that uses Cloud-Init. And I thought that was a huge win. That was really neat and something I was proud of. So,
in your experience, what's been the biggest stumbling block for new users of Cloud-Init?
Well, I think you called out one of them, which is just being able to verify without launch, check, relaunch the user data that's going in. That's definitely been a big one. And also I think documentation has really been lacking throughout the life cycle of the project. That has been improving over time. We've recently added some developers at Canonical to the project, and now we've got a larger team than was there before. And so just, things that unfortunately get shoved to the side due to other priorities, like documentation did over time, that those are we've got some time to work on those things. And so I think it's improving a lot and will continue to improve. And definitely, actually, it's been interesting that as we've gotten documentation written, we've gotten a lot of contributions from users who are just improving docs. Which is really nice. I think, Read the Docs went a long way to providing documentation for Cloud-Init in a place where Google would find it, and then those people, and having that in the source tree and having people be able to contribute to it with a merge proposal has really helped. So it's been great that we've had a lot of contributions that just improve documentation. So that's been great.
And have you been happy with the choice of Python up to date? And if you were to start the project all over again, do you think you'd make that same decision?
Yeah, I think that I've definitely been happy with with Python as a language choice. If I had to do it, if I had to start all over, Go is a language, Golang, that people are picking up to do a lot of these sorts of things. I guess my issues, the problems I've had with Python as a language choice are the biggest thing for me was the Python 2 to Python 3 transition and the pain that involved. I think, anybody who's been active with Python development for any number of years really has been bit by that, and bit by the fact that, the two things are close enough, but not but are not the same and will bite you. There's lots of pointy, sharp objects at the end that'll catch you, and definitely I've been caught by my share of them. So the other thing that I've been struggling that we've struggled with is kind of the performance of Python, primarily from, I think, startup cost, and a lot of that is probably both can be improved by Cloud-Init's code and also by reduction on the number of libraries we've used. Throughout Cloud-Init's history, whenever there was something that we wanted to add, a feature to add, you're kind of, as a developer, you're given the option to either look for something that exists. Often you'd find that on, there was a Python module to do something, or you can rewrite, and you then have the choice to either use that or write your own. And, there's reasons for both, but I think a lot of cases we've ended up with, I ended up choosing to not implement my own when taken a Python project and it's a dependency that then has cost us in startup time or in footprint dependencies and things. So I guess an example of that would be the Python pretty table. We just wanted to render something to the console, that IP information, and choosing to do that with Python pretty table, I think, brought in a fairly large set of dependencies that affect startup costs of the Python process, just from the number of stats and things that occur, right? The number of file loads and everything. So that's cost us in initial boot performance, where, if, hindsight being 2020, we might have made different decisions. And I think that's one of the things that kind of Go is able to improve on with a single static executable, or, different design points of Go kind of address those issues, but bring some of their own. So overall, I'm happy with Python. I think it's completely sufficient for what we needed to do, and a lot of the problems that I've had are probably of my own doing. So I won't point the finger at anyone else without what's the saying, if you point your finger at somebody, there's three of them pointing back at you. So I don't mean to badmouth any other project.
Yeah, every programming language is a foot gun of some caliber.
Yes.
Are there any notable features or improvements that you have planned for the future of Cloud-Init that you'd like to call out? Or do you think that it has largely reached a state of feature completeness?
I think that the big things that we'll continue to get improved networking support, and that will at some point improve or include hot plugging of devices. If you add a NIC to a running system, then Cloud-Init will be able to query a data source, query the cloud provider, and say, hey, you just plugged in a NIC. How do you want that configured? And then apply the networking config. So the end result to the user will be that there is, that when they connected a NIC, it got configured in the operating system, which is clearly what the goal should be, but we're not there yet. The second thing is we'd like to be able to do similar things with disks. So you can, on Amazon, you can attach a new volume or attach several new volumes, and I'd like to be able to declare to Cloud-Init how you want those volumes configured. If you attach a new volume that's got data on it, well, what did you want that mounted somewhere, or what did you want to do with that? If it was an empty volume, you wanted to rate it with the three other volumes that you just attached. So we'd like for Cloud-Init to be able to take information that says what to do with those devices and set up the operating system, so that users don't have to do that sort of stuff themselves, because similar to networking being painful. I mean, if you've ever tried to set up in a reliable way disks and file systems across RAID or LVM, or there are lots of sharp pointy objects there too. And then I guess the last notable feature is really just an extension of the hot plug ideas. Over time, we'll get more post-boot actions and being able to respond to the cloud platform in more intelligent ways, and kind of much more do what the user wanted or what the cloud platform wanted to happen. So more magic happens, and the user can not worry about configuration of the operating system, but can kind of instead worry about the things that they were trying to do, which is more important to them.
Yeah, life as a system administrator is full of sharp, pointy edges that we're responsible for smoothing over so that the end users of the platform can do the actual task that they were trying to do in the first place.
Yeah, and nobody sets out with the end goal of, well, only a few people set out with the end goal of setting up a RAID that is reliable, Everybody else just wants to use the block device or use the file system or run the web service that writes to the file system. So.
Okay. Well, for anybody who wants to follow the work that you're up to and see how you're progressing with Cloud-Init, I'll have you add your preferred contact information to the show notes.
Okay.
And so with that, I'll move us on to the picks. And my pick this week is a system that I just set up for using my Emacs editor for managing my email. So I used the Mu4e library along with the MB-Sync tool from the iSync project for synchronizing my email via IMAP and then managing it via Emacs because Thunderbird was starting to chew up too much of my RAM. And so far I've been pretty happy with this setup. So I'll also add a link to my dot files for anybody who wants to see how I configured it and see if it's something that they're interested in trying out. So with that, I'll pass it to you. Scott, do you have any picks for us?
I'll say, honestly, LXD is a neat piece of software. I know that it hasn't received a whole lot of usage for people outside of the Ubuntu ecosystem, or at least I feel that that's the case. But it is a really well written piece of software that can help you to accomplish a whole lot of things. Big difference between other container systems is just that it is a system containers, which means primarily we run sbin init inside of there, so systemd runs inside of that, and there are images published for it, and it's really a good piece of software. I don't necessarily very often give such credit to software as oftentimes like anybody else. You can see the warts, but I am really happy with LXD and my usage of it. So I'd suggest other people take a look at it. Google LXD and play with it.
Yeah, I've been looking at it as possibly a way to replace my use of Vagrant while I'm testing the work that I do with writing salt stack formulas so that I can have faster cycle times rather than waiting for VirtualBox to start up an instance and go through that whole process. So it's definitely one that I've got my eye on as well.
Yeah, and actually so it ties in on Ubuntu. If you've got a ZFS partition, I mean anywhere where you've got a ZFS partition, but since Ubuntu 16.04's got ZFS built in, if you set it up with ZFS, the launches and snapshots are amazing. It's really 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 fast. If you don't have a ZFS file system, or I think it can do it with LVM snapshots, but if you don't have that, then it will basically the launch of an instance requires a copy of the entire file system, to another location. So that's going to be slow, but on ZFS it's amazing. And you can even use it from a loopback file in ZFS, so you don't even have to think about it ahead of time and say, oh look, I'm going to set up a ZFS partition and then do that. It'll just create it all for you.
All right. Well, I appreciate you taking the time out of your day to join me and share the story of Cloud-Init and some of the ways that it's being used. I've definitely gained a lot of utility from it as a way of being able to get my cloud instances to a usable state and be able to work around some of the shortcomings of the other tools that I've got. So I appreciate your work on that, and I appreciate your time, and I hope you enjoy the rest of your day.
Thank you. Thank you very much. You have a nice day.